Moving to the next part. What is a database architecture? Database architecture is a representation of database design. It helps to design, develop, implement, and maintain the database management system. Basically, a DBMS architecture allows the dividing database system into individual components that can be independently modified, changed, replaced, and altered. It also helps to understand the components of a database. A database stores critical information and helps access data quickly and securely. Therefore, selecting the correct architecture of DBMS helps in easy and efficient data management. Moving to the next part, the types of DBMS architecture. There are mainly three types of DBMS architecture: one tier, that is a single tier architecture, or the two tier and the three tier architecture. In one tier architecture, the simplest form of database where the client and the server and database all reside on the same machine. A simple one-tier architecture example would be anything you install a database on your system and access it to practice, say, SQL queries, but such architecture is rarely used in production. The two-tier architecture in DBMS is the database architecture where the presentation layer runs on a client, say mobile, tablet, PC, or similar, and data is stored on a server called the second tier. The two-tier architecture provides added security to the DBMS as it is not exposed to the end users directly. It also provides direct and faster communication. The three-tier architecture in DBMS is the most popular client-server architecture in the DBMS, in which the development and maintenance of functional processes, logic, data access, data storage, and user interface is done independently as separate modules. Three-tier architecture contains a presentation layer, an application layer, and a database server engine. The three-tier architecture of the database is a basically extension of the two-tier client-server architecture. Moving to the next part, that is the three-tier architecture. The basic goal of three-tier architecture is to separate the user application and the physical database, to support the DBMS characteristics, to provide data independence, supporting the multiple views of data. A three-tier architecture separates it from each other on the basis of complexity of the user and how they use the data present in the database. It is most widely used architecture to design a DBMS. The three-tier architecture of DBMS consists of basic three levels, that is the external level, conceptual level, internal level. And also the physical database is termed the physical level. The external level, also known as the individual user view, is the highest level of three-level DBMS architecture. This level describes the user view of database. In this level, only those portions of database are described that are relevant to the user or application program and hides rest of the database details. Each user has a view of real-world representation in the form of that is familiar to him. The external view includes only those entities, attributes, and relationships that the user is interested in. All the entities, attributes, and relationships may actually be represented in the database, but the user will be unaware of them. For example, the employees in the college library will not usually view the fees details of the database as they are more interested in the information such as book issued or books returned. Besides, including different entities, attributes, and relationships, different views may have different representation of same data. For example, some users might view dates in the form of year, month, day format, while others prefer day, month, year format. Some views can have calculated and or combined data that is actually not stored in the database. For example, the ages of the employees can be included in a view on an employee table, but they are unlikely to be stored. Instead, their date of birth would be stored, from which their ages are calculated by the DBMS. The external views are described by the external schema that are written in data definitional language, that is DDL. There may exist a number of different external schemas of the database, one for each user. Creating separate views for database for different user helps in ensuring the database security. When different users have access only to the data that is needed and access is limited to subset of entire database, the chances of security breakdown is minimized. Next comes to the conceptual level. The conceptual level, sometimes known as the logical level, describes the logical structure of whole database for a community of users, that is, the global view of data. It is represented as middle level in the three-level architecture. It is defined by the conceptual schema, which describe all the database entities, attributes, and relationship together with the constraint, semantic information about the data, and security information. There is only single conceptual schema per database. All the data available to the external view must be contained in or derivable from the conceptual view. The description of conceptual view or conceptual level must not contain any storage dependent details. That is, the description of an entity should contain only data types of attributes. For example, the characters, real, integer, etc., as well as their length, such as the maximum number of or characters or digits, but not any storage and access details, such as the stored field representation, indexed, hashing scheme, pointers, etc. While designing the database, the conceptual schema is the first to be defined. It is defined using data definition language provided by the DBMS. Next comes the internal level. The internal level is the lowest level of three-level architecture of DBMS. This level describes how the data will be stored and describes how the data will be stored and describe the data structure and access method to be used by the database. In other words, it holds the information about data. The internal view is described by the means of internal schema written in DDL. There is only one internal schema per database. The internal schema includes how attributes are represented, how records are sequenced, what indexes exist, what pointers exist, and what hashing schema exists, if any, is used. The internal level is generally concerned with the basic following categories: the storage space allocation, say B trees and hashing, access path, data compression and encryption techniques, representation of stored fields, and optimization of internal structures. Now coming to the next part, data independence. The data independence means a change of data at one level should not affect at another level. The two types of data independence that are present in the three-tier architecture are the logical data independence and the physical data independence. Before coming to the part of the physical data independence and the logical data independence, let's first understand why we need the data independence. The conventional systems have very low level of data independence, that is, even a small change of data structure, for example, insertion or deletion of a field in a record structure, usually require one that has to make changes in the several programs. Programs can be dependent upon where the data is located, on specific storage media, whether the data has a specific storage format, fields that have been coded according to certain rules. File records are sorted in a specific manner. So by introducing a multi-level architecture where each level representation, one abstraction level makes data independent, otherwise, if the data is used by hundreds of application programs in large database system, a small change in structure of database may lead to rewriting all the application program, which may be time consuming and costly. So, now coming to the part physical data independence. The physical data independence is basically used to separate the conceptual level from the internal or the physical level. It is easy to achieve physical data independence, and with this type of independence, user is able to change the physical storage structure on the devices which have an effect on the conceptual schema. The examples of changes under the physical data independence could be that it is by the use of new storage devices like hard drive, magnetic tape, modifying the file organization techniques, switching to different data structure, changing the access method, modifying the indexes, and to change the compression techniques or the hashing algorithm. The last part comes to be the logical data independence. The data at the conceptual level schema and external level schema must be independent. This means a change in the conceptual schema should not affect the external schema. Adding and deleting attributes of a table should not affect the user's view of table, but this type of independence is difficult to achieve as compared to the physical data independence because the changes in the conceptual schema are reflected in the user view. The logical data independence is used to change the conceptual schema without changing the external views and external API or the programs. So that's all for today. These are the references that you two can refer, and thank you for being the patient listener.